All right, so if anybody joined late, good morning once again. What are we going to talk today? We're going to talk today about data independence. Okay, I will go ahead and share your textbook so you guys know, at least to some extent, yes, I've seen this somewhere. Okay, so I'm sharing my screen. If you don't see, let me know, but this is what we're going to talk today. Data independence. What is data independence? Okay. There are two types of data independence. Before I go into it, I will talk. Let me bring up my notes here for you guys so you know what I'm sharing. Okay. So there are two types of data independence. Okay, we're going to talk about physical data independence and then logical data independence. What both of them are going to talk about data storage. Okay. Physical data independence is going to talk about where is the data stored. And logical data independence is going to talk about how is the data stored. So let's take an example, like the same banking example we're talking about so far. When you go to the bank and then use an ATM, you don't know when you query your database, when you query your ATM for a bank balance, you don't know what's happening behind, right? So there's a data abstraction. We call it data abstraction, meaning I don't know what is behind, but still I get what I want, okay? Now, do you care where the data is stored, whether it's stored in RDBMS, whether it's stored in the file, whether it's stored in one table, whether it's stored in multiple tables? You don't care, right? Or you don't get to see that. All you want is, you want to understand what is your account balance, or you want to withdraw some money. That's all you are worried about. You don't worry about where is my data stored. Okay, that's what is called physical data independence. What I mean by physical data independence is I don't care where the data is stored as long as I get what I want. Okay, so if I can use a different way of defining it, physical data independence is nothing but your DBMS system should be able to access the data that you need irrespective of where it is stored. Okay, put it that way. And logical data independence is the same way. Your DBMS should be able to access the data irrespective of how, you said, remember how the data is stored, okay? So if we can go back to our tables, slightly here. So let's go back to this example here. So like I said, physical data independence doesn't care whether the data is in table or is in two tables or whether it's in a file. As long as I get the data, I'm good. Logical data independence is saying, so these are the columns. I have student number, name, gender, date of birth, average, and grade. It is not necessary that I should have these columns in this order. I can have student number here, then gender, then name. Or maybe I can have student number, name, maybe date of birth first, and then gender, and then the grade. Or I can have the average and grade in a separate table. So I don't care how the data is stored, in what order, in what form, what order in the table is it stored. Logically, how the data is stored is not my concern as long as I get what I want. Make sense? That's what is called logical data independence. So put it simple, independence means as long as I get what I want, independent of where it is stored and how it is stored, I am happy. So that's more about data independence. So you might have questions in the exam about, can you talk about physical data independence? What is logical data independence? Or they maybe in general, what is data independence? Okay, I just want you to remember the key terms, physical and logical. Physical is the physical address. And if you want to remember it easily, physical means the physical address. Address refers to where. What is your physical address is nothing but where are you located or where do you live? Okay, logical basically means, electronic, how it is stored. Okay, now for this to be achieved, there are different ways or different forms that are used. So we're going to talk a little bit about physical data independence, and then we'll go into logical data independence. So physical data independence is achieved by using different kinds of file system. So question here for you guys, why do we go into DBMS, or we came over DBMS from a file system, correct? Because we talked about a lot of advantages of file system. Advantage of DBMS. So we said, okay, we are moving over from file system to DBMS, right? But you have to understand, even for a DBMS, it's a logical way of storing data, like I showed you in tables, right? Rows and columns. Do you think in the internal storage, whatever storage medium you use, whether it's any kind of secondary device, do you think the data is going to be stored like a table in the memory? No, it's not. Internally, everything is stored in bits and bytes, basically in the form of files again. Okay. Thanks, Ashish, for your response. Yes. So yeah, feel free to put notes on chat, and I'll be happy to be a conversing session. So if you guys have questions or thoughts or suggestions or answers, go ahead and put it on your chat. So the data that we are seeing in terms of tables is not actually stored as tables internally. It's not. It is internally stored still in terms of files. Okay. So the DBMS fetches the data in a way that it's converted, it's picked up from the file system, put it in the DBMS, and accessed. So the difference here is the first file system that we saw is how the data is stored. Okay. The second file system I'm talking is where the data is stored. Make sense? So the data is stored in terms of tables, logically, but the data cannot be stored just like the table in the internal storage. No, it cannot be. Okay. It's internally stored. You should have studied computer architecture, right? It talks about how the data is stored, how your bits and bytes of data is stored. So internally, the tables are converted into files and stored in the secondary device. Anytime you query the DBMS queries the file, gets the data, organizes it in the form of tables, and gives you the data. Okay, presents. It's called a presentation. It presents the data in terms of rows and columns. Okay. So now we said the data is stored in terms of files. Now, for us to achieve physical data independence, again, I'm going to say physical means where the data is stored. Independence says I don't worry about where it is stored or how it's stored. I just need the data. So for us to achieve the physical data independence, we're going to use different types of files or file organizations. File organization means what are the different types of files and how are they accessed. Okay. So now we are primarily going to talk about 3 different types of file organizations. Again, a question in your exams if you're looking from an exam point of view. But even in practical scenarios, this is important to decide what file should I choose if you have an option to choose. Okay. So we're going to talk about first one, serial file organization. Like I said, I extracted notes here, so it's easy for you to remember. So serial file organization is nothing but in that file that you're using, the data is stored in the order of arrival. What I mean by data of arrival is in whatever in whatever order the records come, in that order, the records are stored. Okay. So if I can go back, share quickly this file. I'm going to share my okay. So here, let's look at this file. So here, there's a simple example I put to store all your names. So what happened is there is no order, nothing. I just kept entering name as you keep telling me the names, or as you keep joining the sessions. I just kept adding your names. Okay, somebody joined the session. Okay, let me. So I had Ashish join first, then Nagesh, then Gan, Bharat, Manjushri. So I kept on adding names serially. There is no order in any form. Okay, so this is called serial file organization. in the order of arrival. I stored the names in the order of arrival. Now, if I want to retrieve the data, all right, the intent of storing is to retrieve it for usage later, correct? So now I need some data. I need to know, for example, if Darshan exists in this database or Priya exists in this database. So now what I'm going to do, I have to serially read through this file. Okay, I got to start reading from the first name, Ashish. So my intent is to know if Priya or Darshan exist in this file. So I'm going to take, say, for example, Priya name is my keyword of search, and I'm going to fetch the first record from this file, Ashish. I'm going to match them. Does the first record I selected equals my name of interest? Is Ashish equals the name that I'm searching? No. Then I go to the next record. Nagesh equals what I'm looking? No. Then I keep going, right? Until I find the record that I need. So this is called serial file organization. So the records are stored in the order of arrival. Okay, makes sense? Now, what is the disadvantage here? Let's talk about the disadvantage. What is the problem here? The problem here is this. Assume you have 1,000,000 record and the person that you're searching happens to be the last record. All right, done for the day, right? You're going to be searching, the system is going to be searching for at least a couple of seconds. A lot of times, your interest in practical projects is about performance. As you start working in projects, you'll hear this term, performance and performance and performance. Anything that you do, how does it impact performance? Performance your system, okay? Any software or any program that you develop, you have to understand how efficient it is. A lot of times, like, I have programmers, or I have had programmers with me, they just write programs. As long as it gives the output, they're fine. But when I review that, I'm not happy because they might have written 1,000 if statements. No loops, nothing. They just will write 1,000 if statements. If, for example, name equal to what I wanted, they'll keep writing 1,000 if statements. That's not efficient, right? So you got to go ahead in a loop. So that's where we talk about, in C++, you talk about switch statement, or in C you talk about switch, or while loop, right? So you have to write your programs very efficient, that the performance is improved. So remember this, one key area in a practical projects that's hit for performance is the SQL. I have had SQLs that run for 1 hour or 1 or 2 hours non-stop, and we sometimes end up canceling. I think recently we had a scenario where one of the query was running for 6 hours and we canceled it. Can you imagine? A lot of times the queries run for milliseconds, but we had queries running for 6 hours last week. And what it did, it kind of impacted the other items. Things that should have run by now did not run, so we had to cancel the query. So a lot of times when they talk about performance, they'll come and ask you, can you fine tune your query? So the SQL is the first place, the DBMS or DBA is the first place to be touched for performance. So they're going to ask you, can you trim your query? Can you look at trimming your query? So this could be one place. So you're using a search technique that's not efficient. So you got to go into a different search technique. So the disadvantage of serial file organization technique is that it hits the performance. Okay, the performance is not efficient. The search process is longer. But what is the advantage here? Everything, like I said, comes with an advantage. Every single thing comes with an advantage. So the advantage here is there is no wastage of space. If you see here, no lines is wasted. Every line is used up. There is no empty space. Okay, so thereby there is no wastage of space. And number two, usually a backup is easier. I know all the data resides in one file. I just back it up. My backup is very easier. Okay, so now I'm going to go into the second item. Okay, so remember this is about serial file organization. So now we're going to come into sequential file organization. Okay, this is the second type of file organization. Sequential file organization. Let me open up here and share this one. So, okay. So now I'm shifting over to a spreadsheet. So what I'm doing is, instead of putting in a flat notepad, I'm putting it in a spreadsheet. The advantage of using a spreadsheet is that it's going to allow me to sort the data. Okay. So now I put the records in the order of arrival as I did before. After I enter the data, now I can sort them, right? So I go and say, okay, sort the data. So if I say sort, you see here, all the data is sorted in some order, either ascending or descending, in whatever way you want. Now, for example, all the items are sequentially stored. Okay, the difference between serial and sequential is that serial, I just entered in the order of arrival. Sequential now, I entered and sorted them in some order, okay? Either ascending or descending. Now my advantage here is that if I'm still looking for the name Priya, I know I don't need to scan through the first name or second name because I can quickly skip to the starting alphabet P. Okay, so I keep hitting here P, and then start checking. Keep going. Prajwal, Pranati, no, then Priya, yes, here. Okay, so I found my record in just 3 hits. So the number of hits here is reduced, the time is saved, performance is improved. Make sense? So that is what is sequential is all about. So the data is sorted in an ascending or descending order based on a field. It could be on any field, okay? So here in my case, I sorted based on the name. Assume you have more data here, like date of birth, address, maybe the grades, maybe the marks, whatever it is. I can sort in any of those fields. I can first sort based on name. Then I say, within this, all these people within A, I want to sort them again in some other order, maybe grades, possible, okay? So on any field, you can sort based on any field. Remember, I'm going to use the term, the field on which I'm sorting is called index, okay? I'm introducing a term called index, okay? The column based on which I'm sorting the data is called index. There could be multiple index for a table, okay? Anybody has a clue how it could be multiple index? Why do we need a multiple index for a file or a table? Under what scenario would you need a multiple index for the same table? If you want to take off, I've muted everybody. If you want to take off the mute and speak up, feel free to do that. Okay. We got about 20 people, so feel free, if you want to talk. All right, I'll continue. The reason why we need multiple indexes, Gautam has an answer. He has a question about the different types of languages. We'll come to it in a minute. I'll talk about the application programs in a while. So the reason why we need multiple indexes is a lot of times your search criteria changes. Now I want to search something based on a name. Tomorrow I might want to search based on maybe somebody's address. How many people come from Mysore? Tomorrow I might want to search how many people have got A grade. So my search condition changes. So every time your search condition changes, your index varies. So you can create an index. There is a way in DBMS to create index. So you can create an index based on the columns that you frequently search. So you have to create index so it's easier for you to search. Make sense? Okay, so now let's quickly look at the advantages and disadvantages of sequential organization. So the disadvantage, like I said, there is an overhead of sorting, every now and then. Every time you enter a record, you have to sort, okay? The advantages here is this, the let's records are read to find a match. So generally what system does to find is basically it splits this whole content into half, okay? So there are 21 records here. The system will try to split it into 10, first 10, and then another 11. So what happens is, this is first 10 and this is the other 11. So when I start looking for a particular record, for example, I use a name, I'm looking for Priya. So what it does it splits the contents into two. It sorts it first, splits it into half. It goes to the last record of the first half, checks is Priya the first alphabet P with a H. So it is sorted and this is H. So that there is no way alphabet P could be in this. So it starts looking only the next half because the alphabet P comes after K. So it starts looking only this half. Now within this half, again, it will divide or cut it into two halves. It will make this into one half, this into the other half. And then we'll start searching in the first half, right? So that's how it reduces the number of records searched and the time taken to find a record. This is sequential file organization. Now, my system is a little bit hung. I don't know if you can still see my screen. My system is kind of catching up. Give me a quick second. All right, I think we are back here. Okay, thanks. Okay. So the third one is about random access. So random file organization. Okay, we use the term file organization. Random file organization basically is nothing but direct access to your record. What do you mean by direct access? And if I could open up the third file that I wanted to use. Okay, so this is the third file I want to use. So this is about a random file organization. So in random file organization, what I do is I assign a record number to each record. Okay, so every time I enter a record, I assign a record number. It's more like a key value. Okay, so now what happens is every time I am looking for a record, I will not look based on the name. Instead, I look on the record number. So that way is what happens. Now, internally, I will maintain and metadata. Okay, I'll talk about metadata. I think we spoke a little bit in the first day. So I'll maintain a metadata saying that if you're looking based on the name, this particular name is this row number. So when I look for the record for Priya, let's say, let's use a different name. So for example, Govardhan. So I'm going to look for Govardhan. So instead of looking for the name, the system internally goes and finds a record number and it says, okay, the user is looking for row number 19. So it quickly goes and hits the record number directly. Okay, this is called direct access. Does it make sense? I'm sure these are very basic concepts, so I don't want to spend too much time. So direct access basically in random access file organization or random file organization, the records are accessed based on a record number. It's basically called a relative record number. Sometimes we use the term RRN, stands for relative record number. So every record will have a number from the start of the records. So this 19 means it's a 19th record from the start of the file. That's why it's called relative. Relative means related to the first start of the file, what's the record number. So relative record number, okay? So based on what I'm looking for, it gets a record number and starts looking only for that record. Now within direct access, there are three techniques the system will internally find the record, okay? One is called self-addressing, okay? What is self-addressing means? It finds the record based on the address, okay? I want you to pay attention a little bit here so it's easier for you to understand. So we're gonna talk within random, we're gonna talk about three different types. Self-addressing method. Self-addressing method is nothing but, assume I store three records, just taken for example. I store three records, Ashish, Nagesh, and Maulya. So each record, let's say, takes about 100 bytes of storage, okay? So the first record, this is all about in your internal memory. So I'm assuming it uses an internal memory starting address is 0, and the record for Ashish takes 100 bytes or 100, let's use 100 bytes long. So there are 100 bytes used. Now I put the second record, Nagesh, it's stored right next to Ashish in sequence. So it puts starting from 101, the next record is stored going through 200. So each record takes up the same amount of storage because each record is fixed because we're storing the same amount of data. everybody has the same amount of data to store. So from 101 to 200, I store Nagesh's record. 201 to 300, I store Maulia's record. Okay, now what happens is, now again, an internal metadata is created saying, if you're looking for Ashish, the record is at address 0. If you're looking for Nagesh, the record is at address 101. If you're looking for Maulia, the address is at 201. So that way, when my query runs, the query will say, get me information of Maulia. Internally, the query is converted to select from the table where the address is equal to 201. So it directly hits the address 201, gets the record, gives me the record. Make sense? So this is called self-addressing, meaning there is an address associated, you're reading the record from the address, still it is directly read. I'm not reading all these records like we did in sequential or serial, we're directly reading the record. So easy access, direct access, that's where the name comes. Random access is also called direct access. Okay, make sense? Now, I keep moving. So within random organization, there is another technique called random access. Okay, the random access basically means, all right, before I continue, I know we had some difficulties the last class. So if we get disconnected in a few minutes, I would expect you to join in the other link. I shared 2 links. So I have the second link. So do not join back in the same link. Use your second link to dial in back. I will see you guys in the other link if you get disconnected. If you don't, we'll continue here. Okay. if you need the link handy, just keep it ready. You need to go into the second link. All right. So random access, what basically it does, it creates a hashing algorithm. The advantage here is, okay, we didn't see the advantages of self-addressing. The advantage of self-addressing or the requirement is here, all the records have to be a fixed length, okay? If the record length for Ashish uses only 60 bytes, still under self-addressing, it will use 100 bytes. For example, his address is smaller, let's say, he doesn't have such a big address. So his record, let's assume, is only 80 characters long. Whereas let's say, go to Maulia has an address, maybe street number, floor, apartment number, street address, etc., etc. So the address is longer. Let's assume the record length for Maulia is 100 bytes long. So it's irrespective of whether it's 80 or 100 in self-addressing, all the records are assumed to be fixed length. If they're not 100, spaces are paired up to make it 100 characters long. Okay, so there is wastage of space. Okay, so they have to be fixed length, but at the same time there is wastage of space. The other disadvantage is if I delete this particular record, okay, for example, second record, for some reason that student is not here, I wanted to delete the record, it just leaves that vacuum, okay? It doesn't create or it doesn't reassign that space to somebody else, or it doesn't move the records to the forward. Okay, so that's a disadvantage. So if there is an empty space, the empty space is not used until there is a reorg that happens. There is an item called reorganization. When we do reorg, all your empty spaces are cleaned up. So until a reorg happens, that space is not used up. So don't get into reorg now. I don't want to complicate it. Okay, let's get into random access. So in random access, what happens? An address is created randomly based on a key field. For example, based on the name, I create a random address rather than a sequential address. Like here it is a sequential address. I create a random address. For example, it goes through a formula and then it creates an address and then says, okay, Ashish's record will be stored in address 1842. And then Nagesh record will be stored in 2902. Things like that. And it creates an metadata. Okay. So this is how it looks. So it says Ashish is stored in F14. So F is this column and 14 is this my record. So Ashish is stored in F14 is the address. So it creates it creates a hashing algorithm. And then same for Nagesh, it creates an address model. So anytime I start looking, I go fetch this record. I go to this F14, get the record. K13, I get the record. O16, I get the record. So far, so good? All right, so let's assume that as an yes. Now, The problem here is this, or basically I should say, the first